Next, let's talk about types and structure of solids. In this module, we are going to be talking about the solids based on their bonds, the bonds that arise to their formation. On another this module, we have 4 types of solids. We have covalent solids, we have ionic solids, we have molecular crystals or solids, and finally we have metallic solids. Let me start from bottom up. Metallic solids are those solids that are formed as a result of metallic bonds. Example is iron bars, we have chromium steel, and several other solids that are formed by metallic bond. Next up is molecular solids or crystals. These are solids that are formed by interactions among the atoms of the molecule to give rise to a solid, a crystalline solid rather. One of these most common example of these is iodine crystals, held together by van der Waals forces. In fact, van der Waals forces is the major culprit found holding molecular solids together. Next is ionic solids. These are solids that arise by virtue of formation of ionic bonds. Example you find is crystalline solids like sodium chloride, potassium chloride, and etc. These solids have ionic bonds holding them together. Next up, we are going to be looking at some major covalent solids, graphite and diamonds. Graphites and diamonds are covalent solids but formed by the same compound, carbon. In fact, in subsequent sessions, you will learn about allotropy. Diamonds and graphites are allotropes of the element carbon. An allotropy is a phenomenon where a particular element in the same state can exist in different forms. Let's look at an X-ray of diamonds. Diamonds are covalent solids, as I've mentioned before. They are octahedral in shape, and the octahedral lattice is made up of tetrahedral unit cells held together by strong covalent bonds. This structure makes diamond the hardest known substance on earth. There is a popular saying among miners that it takes only a diamond to cut a diamond. Uses of diamond. There is a saying that a diamond is a lady's best friend because diamonds are used in jewelry. But more importantly, diamond is used predominantly as a cutting tool by miners and geologists when undergoing underground exploration. Next up is graphite. Graphite, like diamond, is made up of entirely of carbon. It's also an allotrope of carbon having hexagonal units, hexa 6, joined together by covalent forces, and in between them are unit cells having, each unit cell are partially held by van der Waals forces. This implies that although in graphite there are van der Waals forces and covalent forces playing a role in its structure. Uses of graphite. One of the most important uses of graphite is an electrode. Because graphite have free electrons in its unit cell, it is often used as an electrode in batteries. We call it carbon electrode. Next up, graphite is used as a lubricant as well. It's also formed in making pencils. The lead in pencils is often made up of graphite. Finally, in this session, we are going to be talking about determination of boiling points of covalent solids. The boiling points of covalent solids are usually lower than those of their ionic counterparts. The reason is not far-fetched. Covalent bonds are of weaker strength than the ionic bonds. but the number of covalent bonds can actually play a role in determining the boiling point or the strength of the strength of the bonds in a solid. Diamond is made up of entirely of covalent bonds and is the hardest known substance because there are multiplicities of covalent bonds in a single unit of diamond. So let's look at the factors that can help us in determining the boiling point of covalent solids. One, since they have weaker forces of attraction between them, they are of lower boiling points than their ionic counterpart. Example, we can find in graphite. Two, some of them are soft, causing them to have low boiling points. Graphite is another culprit under this example. And finally, the number of covalent bonds play a role in the strength, as I mentioned before, and this causes diamond to have a very high boiling and melting point. Thank you for going through this session with me. In the next video, we are going to be solving past questions from UTME and SSCE based on trends in the last 5 years on this topic.